Hey everyone. So today, as you can see, we have a fun little topic, factorization of trinomials using tiles. It's an interesting thing that I found on the net that I wanted to share with you guys. And this is how it looks. So let's have a square and a rectangle, a blue rectangle, and a little square again. So this square here, we'll say it has side length x, which means it also has the width of it as x. So which means the area of the square is x squared. Okay. Now, this means that in an expression where we have x squared, we would be thinking that this green square represents that x squared term. Then here we have a rectangle which also has the same length of x, and its width is 1, which means its area will be 1 multiplied by x, and that's x. So it means this blue rectangle will be representing the x term. So if we have 2 of them, it will be 2x. If we have 2 of these, it will be 2x squared. And then this one has width of 1 and length of 1, which means it is a constant. It will be representing the constant term in the trinomial. Now, if we have the constant term as -6, there'll be 6, or positive 6, there'll be 6 of these ones. Okay. Now, one thing to note is that since x is an unknown, we cannot stack these purple squares along the length of this rectangle to see how many ones make up an x. So we don't know how many. So this is just supposed to represent an unknown value. It doesn't necessarily mean that if they look like 4 of them can fit here, it means x is 4. So we are not going to be stacking the constant term along the unknown term. It's always going to be along the side of the rectangle that we know. Okay. Now, since we've defined the positive terms x squared, x, and 1, we can also define their negatives. So I've decided to use red as the negatives of each of these things. So when you see a red big square, we know that's negative x squared. And when you see a red rectangle, we know that's negative x. And then a red little square that gives you -1. So it means if we have -6, we will have 6 of these. If we have -2x, we will have 2 of these red ones, and so on and so on. Now, these two are called the zero pair. So when we have an expression and then we bring onto the screen more of these rectangles, but we bring a blue one and a red one, it would mean that we've added 0. We have not changed the expression. The expression remains as it was. Even if we bring 2 of these and one of them is purple and the other is red, we know that that's a 0 pair. You've essentially added 0. Okay, you'll see why that matters later. Okay, so now let's see an example of how to do these things. So when we have this situation here, this tells us we have 1x squared, 3 x's, and 2 units. So this is x squared plus 3x plus 2. So this represents this expression. Okay, now to factorize this expression, we are going to try and form or build a rectangle using all these things. So we're going to stack. Remember, the rules are along the square we can only put this length of the rectangle, and along this bottom side of the square we can only put the length of the rectangle. It means we'll have to rotate this rectangle and stack it below here, rotate it 90 degrees. So these little ones here only can stack along the shorter sides of the rectangle. So now the only way we can do this, or maybe one of two ways we can do this, is to do this. As you can see, we have stacked the whole shape to be a rectangle, and the ones are stacked along the side length one of the rectangle. That's why they fit together so nicely, and then they form a rectangle. Now, once we have this rectangle, it means we can see what the new dimensions of the big rectangle is, and this is going to be x plus 2 ones. So x plus 1 plus 1, that means this is x plus 2. And down here we have x plus a 1, that's x plus 1. And funny enough, these are the two factors of this expression. That's how we've demonstrated that this expression can be factorized into these two binomials multiplied. Let's see another one. Say we have one big square, 6 of these blue rectangles, and 5 of these little purple ones. So obviously we see that this is x squared plus 6 plus 5. That's the expression we have here. Okay, now we're going to try and form a rectangle using them. So we will have this situation here. So again, we have a 1 here to accommodate these little ones here. Then we stack the rest of them this way, and then they form a nice rectangle. So it's almost similar to the one we just did before. So it means the dimensions of the new big rectangle becomes x plus 5 of these little ones. On this side we have x plus 1. So that's x plus 5 and x plus 1, and indeed these are the factors of this trinomial. Okay, let's see one that's a little bit different. So now we have red things now. So the expression now becomes x squared. This is still a positive x squared, and this is a negative x, and these are 6 little negative ones, and they add to give us minus 6. This means this is x squared minus x minus 6, and we are going to try and form a rectangle using this. Now we can see that this is going to be a little bit of a problem now, because remember we said we cannot stack the little ones along the side, and we only have one of these. So trying to do it, we get a situation like this, and now we needed a 0 pair to come and help us fit the empty spaces to form the big rectangle that we want. So the first 0 pair that we brought here will fit over here, but we still need another 0 pair down here. So let's bring another 0 pair. Remember, bringing these two is essentially adding 0. We've added an x, subtracted an x, added an x, subtracted an x. So we have not changed the expression, it's still the same expression. So let's put them in and form our rectangle. Oh yes, and then another rule is you stack the red ones on the same side of the square and the blue ones on the same side of the square. Don't mix them up and find that this is red, blue, red, and so on. Now this has formed a rectangle like we wanted, and we can now look at the dimensions. Dimensions are now x plus 3 -1s because they are red. So it's actually x minus 3. But this side we have x plus 2 because we have blue rectangles here. And then that's the factorization of our expression x squared minus x minus 6. Now please, you can maybe cut out some little cardboards and color them, and then give learners to play around with them and see if they can factorize each and every trinomial that they can factorize manually. If they can visually make this colors and play around with them. So I will investigate on how to do the other ones, the difference of two squares, and when we have a term that is double the x squared term here, or triple, or whatever, and then maybe I'll come and share the video again. But for now, like and subscribe, leave comments in the comment section below, and I'll see you in the next video.